Alrighty, we've got another exponential and logarithmic real-world problem. This one is about something called half-life. Half-life is the time required for any specified property to decrease by half. It's most commonly used in a field such as chemistry or geology. So you might see half-life about a radioactive substance, because that would be the amount of time it takes for that substance to decrease by half. You might also see it when we're talking about drugs and prescriptions. There are active elements in those drugs. They also have a certain half-life where it's going to decrease by half. So the formula for half-life is N equals N sub 0 times 1/2 to the power of T over H. N is the future amount, how much of that substance you'll have in the future. N is the amount that you have right now, or how much you started with. T is time. This time does not have to be in years. It can be in months or days or whatever. And then H is the time of half-life, which we will give you. An element has a half-life of 30 days, that's our H. If it starts with 100 milligrams, that's our N sub 0. Find the amount of the element remaining after 150 days, that's our T. Again, T does not have to be in years when we're talking about half-life. So we're looking for N. We want to know how much will be remaining in some future number of days. So N equals our initial amount times 1/2 to the power of T over H. The variable's all by itself, so we can go straight to the calculator. This one's very nice. 100 parentheses 1/2 to the power of 150 over 30, which is 3.125. So in 150 days, there will be 3.125 milligrams of this substance. The half-life of carbon-14 is 5570, that's H. If the amount of carbon-14 in a fossil has decayed from 200 milligrams to end up at 90 milligrams, how old is the fossil? We started with 200, that's our N sub 0. We ended up with 90, that's our N. How old is this fossil? So how long did it take to get from 200 to 90? So substituting what I know, 90 for N equals 200 for N sub 0 times 1/2 to the power of T over 5,570. We're solving for something that's in our exponent. I'm going to start by dividing 200. So I have 90 over 200, which is 9 over 20, equal to 1/2 to the power of T over 5570. Can't make these the same base, so I'm going to change it to logarithmic. My base here is 1/2, so I have log base 1/2 of 9 over 20 equals T over 5570. To get T by itself, I'm going to multiply by that 5570. T equals 5570 times log 1/2 of 9 over 20. Here we're going to use that change of base rule. I'm going to do log of 9 over 20 divided by log of 1/2 and then multiply that by 5570. And I got 6416.66. Since we're talking about T in years, I'm going to call it 6,417 years.